Hi, everybody. I'm here to talk about how to break up with your test suite. My name is Justin Searls. I am Searls on Twitter. I'd love if you followed me and gave me feedback whether or not you like the talk. Or you could say hello at testdouble.com. My company is TestDouble. We're a software agency. We're all virtual, but most of us, like me, come from Ohio. And if you have any questions today, this talk is going to be really, really fast. So I don't have time to take questions during or after the talk, but please just tweet at me during the talk as the question comes up. There's a lot of content, and the favorite question gets a book. Yay! But just to kick things off right off the bat, this is a talk about relationships. Testing is a contentious issue. People have a lot of emotions tied up in the topic of testing for whatever reason, and I'm not here to talk about a right way or a wrong way to do something. I think that there are plenty of right ways, but there are thoughtful approaches and not so thoughtful approaches. And my goal here today is just to espouse a particular thoughtful approach to try to get you thinking about how you might be more thoughtful when it comes to the topic of testing. I really love my customers. I love the feeling of delivering something that's going to provide them value, that serves their needs, that saves them time, or makes them money. I love coding. I love writing a line of code and getting everything to actually work, finally. I love green bars. I'm addicted to green bars. I love seeing a test pass after all the machinations necessary to make that happen. But I don't test for testing's sake. I don't write a test just to make me happy. I write tests to make code work. I mean, leave it to Kent Beck, the guy who invented test-driven development, to point out in a one-off comment in a Stack Overflow thread that he gets paid for code that works, not for tests. So his philosophy is to test as little as possible to reach a given level of confidence. Testing is not an end itself, but neither is coding. We don't code for coding's sake either, at least not when we're getting paid for it. We code to solve problems. In fact, I just think of writing code as a costly way to solve a problem. If I can solve my client's problem without writing any code at all, I'll always prefer to do that, because the carrying cost of code is always a lot higher than we think. Too often, I think that we cheat on our customers with our code. Here's a how-to guide on how to cheat on your customers with your code. Step number 1 is to uncritically assume that your favorite way to write code applies to every situation. And then there actually is no step 2. Step 1 is plenty. I see this a lot. I see this a lot, especially among consultants, but really all of us who in the Ruby community think that we have our way figured out. And I call it cargo culting as a service. I think that we need to, in order to grow, we have to continue to challenge our biases in every new context we find ourselves in, and really seriously ask, is TDD useful in this context? Is Rails the right choice? Should I be using Ruby? And asking hard questions, because only if we ask those hard questions and evaluate them whether they're useful in each context, will we know whether or not they're the right tool for the job, and they continue to be. Infatuation with tools, with ways of writing code sometimes sets in. You might remember in 2006, Brian Lyles gave a talk about test all the freaking time at RailsConf. And the Ruby community has a special relationship with testing because it was one of the first language communities to really embrace TDD and automated testing. And so at the time, I remember a bunch of my friends had this face on, that TDD was just literally their savior. They were super duper excited and they got a lot out of it. But then you come to their code base 6 months later and they start questioning themselves. Like disillusionment sets in. Why does every refactor seem to break 6 of my tests? Why does the build suddenly take 9 hours to run? Why are people mocking methods on the object that they're testing? And why can't we get anything done anymore? At first, TDD seemed like it was speeding us up and making us so productive, and now it just feels like all of our tests are this albatross. And then, of course, eventually, the breakup. The team has become disillusioned with testing, and they've either stopped writing new tests, or sometimes they sort of chat at lunch about, hey, wouldn't it be awesome if we could just RMRF spec and features and start fresh and just write code again? Introspecting why this might be, I think it's important just to back up and talk about why we test. I recently had a new client who, in the 15 years of TDD being a thing, none of them had ever written any automated tests. And it was a really, really talented engineering group of about 20 people. We sat at a whiteboard and we talked about, what do you hope to get out of this new endeavor that you're going to take, where you're going to include some tests? And the first thing that the steps 1 through 10 of what people wanted out of testing was to know that their code was working. Other people pointed out that they wanted to be able to safely change and refactor their code. Obvious stuff. But more subtle stuff started bubbling up. Like, they wanted the test to encourage them to keep the product simple, They wanted the test to encourage that their public API be easy to use, be usable. They wanted to also grow a maintainable private API so that 2 years from now, story cards didn't take forever long to implement. They wanted to ensure, there's a service-oriented architecture, ensure that the behavior of the other services that they depended on was working. They also wanted to verify that production is working. They had certain things that they wanted to test live against production, which was interesting. They wanted to safeguard their use of third-party code. They wanted to validate that their code, that their services were useful to the other teams. And they also wanted to narrowly specify the dependencies that they had with third-party libraries and network services. Now, 5 of these things, they're about confidence, using tests, running tests to tell you whether or not things are good or not. The other 5, those are really about understanding. The value there is mostly in writing the test and maintaining the test. It's our ongoing relationship with the test that, in and of itself, informs the design of our systems. But before we could solve all 10 of those motivations, we have to kind of consider how you assign responsibility to tests. Today, I'm going to kind of talk about single responsibility testing and what happens when multiple responsibilities get put into a single test. So pretend that I'm test driving a new Panda object, and the Panda I know is going to need some bamboo, so I create a fake bamboo. I pass it to my new Panda, and then my specification is simply that it munches the bamboo. And so I call the subject's method eat, and then I expect that the bamboo would have received the message munch. And I've got a working test now, and the bamboo doesn't need to exist, but I specified a little bit about the panda's behavior. And so as a discovery test, this is useful. But then later on, fixing a bug, I come back to the test, and maybe I'm fixing a database-specific thing. Now my hat isn't so much about discovering the system, it's about fixing a very specific database integratity problem. And I'm like, oh, this test is useless because it's not realistic, so I need to replace that bamboo with a real bamboo, so I'm going to go find it in the database. And which, of course, immediately breaks the first test, which was using a mock. And now I have to say, well, hold on, allow the bamboo to receive the message munch, making the bamboo no longer a real bamboo, but a bamboo with a hole poked into it. Now it's a partial mock. Now I can write my test, which is more concerned about reality, like say maybe that eat method is supposed to return the ID of the bamboo that was passed to it. So now I've got my confidence that I fixed my bug, and I still have my original motivation here. It's just a little bit confusing possibly, because of course when I return to it later, I'm going to look at this code and try to understand what the hell's going on. Why does that test exist? What type of test is this? There's some mocks and there's some integration. And what does this say about how tests should be written in this code base? I think that we should know the answer to all of those things before we even open the test. Based on where the test is or how it's named or how it's organized, the basic rules of the game should always be immediately clear. The purpose of the test, the rules that govern how we write those tests, and then the basic conventional structure of those tests should always be immediately clear before we even open them. And a single test, as a result of that, can't possibly address all of our motivations. So we need to split up into multiple test suites. Now tests like that are they're fundamentally unclear because when you think about them, their purpose tends to be kind of hazy. The rules are always debatable. The structure tends to be ad hoc. And I think that unclear tests cost money because when you have that unclear test, what that basically means is that you're constantly having to rediscover the purpose of the test. You're renegotiating what the rules are. Hey, we can use mocks here. Hey, this is over mocking, et cetera. And the structure needs to be reorganized in terms of, well, do we do it by methods or behavior or whatever? None of those activities have any value, but they all take a lot of time. And I think they aid in the disillusionment that a lot of us feel about testing. So today, my thesis is that every test suite should promote at most one type of confidence and one type of understanding. If we get ancillary benefits, that's great, but it should be clear to everyone what the confidence that we hope to get out of this test is and what the understanding that we hope to get out of this test is. So let's talk about suite design. First, just talking about Rails, because I assume that a lot of us know about Ruby on Rails and how testing works in the Rails community for the most part. So Omakase Rails out of the box will encourage you to write mini tests. You can write mini tests against your view objects, mini tests against your controllers. You can write mini tests against your models. And each of those calls through to the layer beneath it all the way to the database. We also have the prime Rails stack that you might use, Cucumber and RSpec or just RSpec, but you might have Cucumber tests that exercises the user interface with web automation. You might have RSpec against the views, I suppose, if you're really ambitious and you also test that. RSpec against the controllers, you could have RSpec against the models, but sort of like Omakase Rails, all of those call through to the next layer beneath them, all the way down to the database. Now there's also a group that practices like what they call fast specs Rails, where they kind of cordon off as much logic as they can outside of the Rails stack so they don't depend on it. So they can write fast RSpecs that don't load all of Rails against just plain old Ruby objects, which are then required or depended upon by our Rails application. What's the problem with all of those approaches? I think it's redundant test coverage. If I want to make a change to just the very, very bottom, the very core of my behavior, like in a model, first I'd write a failing RSpec, then I'd update the model and make that RSpec pass. But my work isn't done yet because it's like layers of an onion that's going to have a ripple effect in all of the integrated tests above me. It's going to probably cause my controller spec to fail if it was a significant change, cause my view spec to fail, cause my UI spec to fail. And this is just the out-of-the-box layers of the onion. Odds are we're adding new domain layers and levels of indirection and relationships in between. I had once a rounding error was fixed in a financial calculation on which like 7 reports relied. And I remember the poor schmuck who pulled that 1-point story was fixing tests for like 3 weeks. And then he quit. So all of that just leads to what I call table flip Rails, which is that I only write RSpecs against the UI, and then I just say fuck it for the rest underneath that, which isn't fun because I love testing. I actually write fewer tests on my Rails code now than I do pretty much anywhere else. So I want to hit the reset button and talk about alternative designs of test suites in environments outside of Rails and see how that might inform us in our future work. So first I want to give an overview of a different type of an architecture. This is the same client that was at the whiteboard earlier. They had an application that, to zoom out completely, exists in Planet Earth. And just a level beneath that, it was served up on Amazon Web Services in the cloud. So when you zoom in and actually look at what the application structure was like, it's a whole bunch of microservices. There's an inbound router that routes HTTP requests to a couple of web applications. Those web applications all talk to data services a layer beneath. And if you zoom in on what do those web applications look like, front end was all fat client JavaScript. They were using Angular. Then there's a web backend. They were using Node.js, but they could have just as well been writing Ruby. The object model for that backend might have looked something like this, right? Like a feeds zoo animals would take the inbound request, and then ultimately it would query a meal plan and then release it through the cage. And then zooming way in, an example class might look like that. So there's all these different levels that we're going to zoom in and out of today as we discuss the different test suites that address each of the needs of those levels of granularity. So talking about suite design, I'll zoom way back out to Planet Earth again. At the very top level, I'd be remiss not to mention that the greatest test of all is to answer the question, does our software serve its purpose? And then a lot of times developers, I think, do a bad job of remembering like what the purpose of the software that they're writing for a business is. Like a lot of developers I talk to are not clear whether the purpose of the software they're writing is to generate revenue or to cut costs. That's probably 80% of the software that we get paid to write is going to be one or the other. But it's really important to know because they have different motivations. Sometimes the motivations are more interesting, like limiting an organization's liability. Or one of my favorite clients at Testable is Investigative News Network. We help them fund nonprofits. Can we write a test for those outcomes? I'd love to be able to talk to you about that, but we don't have time. The answer is maybe. Sometimes you can actually like automation test bank statements. But we don't have time in this talk to cover it. So I'm going to zoom in slightly more than Earth and just talk about the application as it exists for this particular client out in the cloud. You might call tests at that level smoke tests, or acceptance tests, or feature tests. You might call them end-to-end tests. You might also call them integration tests, but today, integration test is a 4-letter word. I don't like the phrase integration test because no matter like what your perspective is, every test could be considered an integration test by somebody, and it's just an overused phrase, so we're not going to use it. But when you look at these other 4 tests, they all have nuanced different meanings, but they're all kind of getting at the same thing. So today I'm going to make up a new phrase because I like acronymizing stuff. I'm going to call them safe tests. So this is my safety suite because I'm hoping to get safety out of this test suite. For each suite that we talk about, we're going to cover 5 different things that we're interested in. First, the user of the test. What hat are we wearing? The confidence that we hope to get out of this test. The understanding that we hope to get out of this test. Then a handful of guidelines about how to write these tests well. and some warning signs, that just typical problems that we ran into trying to write these tests. So talking about the safety tests, which serve as the final safety net of our application, the user should be as close to a real-world user as possible. That means if it's a web application, we should probably be using web automation to automate a browser against the application. If it's an HTTP service, we just need to write tests in something that can talk HTTP. I don't care if it's curl or a library or a rack test or whatever. The confidence that we hope to seek, obviously, is that when it's all glued together, all these different services, that the application seems to work. It's real simple stuff. The understanding that we hope to get is more interesting. How simple is our product? Because if we can't fit in a 30-minute test suite all of the things that you can do with the product, then obviously the app is complex. But similarly, if you can't write a new test inside of 30 minutes, then perhaps the app is complicated. Something about the implementation of the app makes it really, really difficult to even tell whether it's working. Some guidelines around safe tests is that they shouldn't know about internal APIs. If they know about internal APIs, that means that a course of business change to the design of the application that's not visible to a user might end up breaking that test because of that coupling. For example, web tests should try to bind to user-visible stuff, like the text submit on a button, as opposed to the class or the ID that we use. Because if the ID changes, that's not meaningful to a user. But if the word on the page changes, then that is. It's not always possible, but it's what I try to strive for. Also, another fun idea, at this particular client, they were worried about the eventuality of having like 3 years of tons and tons of tests that were really integrated. So from day one, we enforced a time box, a budget, on their safety test suite. So I drew up on a whiteboard a 5-minute by 5-minute graph and told them, literally here, plot all of the time durations of your individual tests. And once this box fills up, then something has to go before something new can be added. So for example, maybe they had 7 minutes in a test of some monthly financial reporting, 4 minutes tied up in search, 6 in processing orders, 4 they actually had to test the AdWords were displaying and working on their page, because that was a major source of revenue. And then also 4 minutes on the sign-up workflow. So when an executive comes by and says, hey, we need this new daily deals offer, and I need some tests around that, then they have to ask that executive, well, that's fine, but what's going to come out of our integration test suite in order to make room for that? That way it can never balloon into this 10-hour Goliath. So warning signs, just like I mentioned earlier, that if you're experiencing failures just because somebody refactored something, that's a false negative. And throughout this talk, be thinking about false negatives versus true negatives. When you get a test failure, it should be meaningful. It should be an indication that something actually went wrong, not that a test just needs to be updated. Also, beware that human intuition tends to overvalue more realistic tests. We feel a lot more comfort when we can think that the test is actually everything is all plugged together. And so these suites tend to become too large when what we're really trying to seek is confidence that stuff is working. Also, when you have lots of live releases of your code, if you're not just a .com, but you actually release your code into the wild at multiple points and you have to support multiple releases, or if you try to build all your feature branches, this test suite in particular tends to become really, really expensive if you try to run it on head of all of those different branches. There's also to worry about superlinear slowdown. Superlinear slowdown is a term I got from J.B. Rainsberger a while ago. Basically, it's real simple. If you have more tests, your build is going to be slower. That's obvious. That's a linear growth. But as your system gets bigger, each of those tests are also going to individually run slower. So while we think that one test means that we're going to just run linearly more slowly, as time goes on, that system gets bigger and it actually starts to look like a geometric curve. That's how your 2-hour test suite in September ends up being a 6-hour test suite in December, even though not that much happened. Safe suites address 2 of those needs that we had on the whiteboard. First of all, we can verify that a production-like system is working, but we can also get a little bit of feedback and understanding about the simplicity of our product, based on how many failures there are, based on how easy it is to write a test, based on how long the test suite needs to be. So let's zoom in a little bit from the app into an individual service in the application. This one has a web JavaScript front end, let's say a Ruby backend in this case. Now, obviously, safe tests are very accurate. They're very thorough. They're very reliable in terms of telling you whether things are working or not. But they're also, like we just mentioned, very expensive. And more importantly, in this case, they don't inform us about the design of our public APIs, how one service talks to another. They don't tell us whether our individual services are useful or not, or libraries. So every library or service that you write it's consumed by somebody. So you can verify the behavior of your consumable or demonstrate its usage by writing what I call consumption tests. A consumption test, the user, the hat that we wear when we write these tests, is whoever's using our thing. So if we're writing a service, it might be it's somebody calling us with HTTP. If we're writing a library, it might be somebody just using our API like they'd find it on the README. If it's a user interface, it might be an automated UI tool. Whatever our repository does, a user of that repository is the user that we're thinking about when we write this test. And the verification that we're hoping to get, the confidence, is that we can verify the behavior that we are directly responsible for. Every line of code inside of that repository that we're responsible for is being exercised in a realistic way. And the understanding that we get, obviously, is it usable? And the best test of whether or not it's usable is if it's hard to write a test, then it's probably also hard to use. If you're using it as a user would and you can't test it easily, then how could you possibly use it easily? Some guidelines here. When you try to slice stuff up into little bits, it can be really tempting to just do it arbitrarily to make your test happy, but it's much more useful to be thoughtful about what are meaningful modular boundaries. Like, for example, breaking out fat client JavaScript frontend from HTTP service backend and putting those into different directories or different repositories has tremendous value outside of just testing. We can reuse that backend if we want to go build a mobile application. Another guideline, we try to fake all external dependencies. That way we can run this really, really fast. So for example, that means you should be able to run your consumption suite without access to other services in your enterprise. For example, you should be able to run them in Travis CI. I pushed this particular client to use Travis on all of their repos because I knew that they wouldn't be able to phone home to their legacy data services. And there was like 30 developers, and I didn't trust that everyone was going to get on board this train right away, so I forced them with the tool, which is not how you're supposed to encourage people to do stuff. Also, like before, exercise public APIs, not private APIs. Private API usage is probably going to be necessary for setup and teardown, but be aware of mixing them together too much because it can be confusing. It creates the same exact coupling that can be problematic for our safety tests. Refactors will just break these tests meaninglessly. And I like to organize them by the consumer's desired outcomes instead of by like class names, for example. That way that there's a little bit of indirection between what the test is hoping to accomplish as opposed to the structure of the code at any given moment. Some warning signs, like I mentioned, you want to keep consumption tests really, really fast. The reason is that they're your safety net. Also, if you're faking all your services, there's no good reason to be slow. If it's slow and it's a consumption test and you faked everything else out, its slowness is your fault. So you can go and figure out how to make it faster. It's actually pretty good feedback about areas where algorithmic complexity is actually a problem. And that's normally something that's hard to suss out when network requests are orders of magnitude slower than any of our algorithmic stuff. It's also the only suite that has any hope of telling you that you just broke something. It's your refactor safety net. So consumption tests help us safely change and refactor our code. And then they also give us feedback about whether our API is easy to use. Zooming out just a little bit, though, and talking about that service in the context of all of the services of our application, it's easy for somebody to want to ask, if my test fakes out walrus service, how can I trust that get walruses still returns walruses? I'm faking it out. My confidence level is lower. Help me out. Why not test across service boundaries? Why not really call walrus service? Well, I've got a three-step guide that makes inter-service testing really easy. The first step is to start by not writing them. The second step is to continue to not write them. And then the third step is that you're actually already done. Wasn't that easy? Inter-service tests are really tempting for that reason because I think, like I said, our intuition favors integratedness. But they're hard to set up. Like just logistically, if they're running in Travis and they require another service, it's a pain in the ass to get them all to talk to each other. They're slow to run, obviously, and they represent redundant test coverage in the same way that Rails default test suites are also redundant test coverage, and they have the same associated cost to change. And besides, the root question here really indicates a lack of trust. I don't trust that walrus service, a system designed to get me walruses, is going to continue to give me walruses. It's a sort of ridiculous statement, but our trust level of the things that we use as developers tends to be so low that we don't really realize the ridiculousness of that statement. So first, I'd encourage folks to just default to trusting the services on which you depend. Right now, I'm just talking about other internal services that are maybe managed by you in another context, or maybe another member of your team, or another team in your organization. So default to trust. But sometimes, honestly, trust isn't enough. Trust isn't appropriate. And you can think of cases where maybe you know that your usage of a service is abnormal. It's off to the periphery of the priorities of the person who maintains that service. Or sometimes your usage is literally unsupported. You know that you're kind of skating fast and loose. Also, sometimes other teams demonstrate blind spots. Maybe they have a regression that keeps getting into each release, and they keep breaking that one thing about walruses that you need over and over again. So when trust isn't enough or when trust isn't appropriate, I try writing contract tests. I think contract tests are tremendously useful, and here's how they work. First of all, the user is easy to understand because the user is you. What you're doing is you're going to write a test that's written to represent your own interest as a user of that service that isn't yours, and then you commit that into somebody else's repository with your name on it or in a directory that represents how to get a hold of you. And then your needs, whatever they are, those become part of that team's consumption suite. So they don't maintain that test per se, but if that test breaks, then they know exactly who to call. They've just made a change that violates somehow your expectations. The goal here, obviously, from our perspective as a user of another service, is speedier feedback. So if normally I have to wait until that service team does a production release and then wait for stuff to blow up, that's a very slow feedback loop. But if I can just know that as soon as they get pushed, they're going to get an early notification that that one quirky thing that I need about their service is still working, that's way, way nicer. And where at the production release, it could be like me calling managers and getting really upset and crying on the phone. Git push and an early test failure, that's an easier conversation to have because bugs are so much easier to fix the sooner you find them. The confidence we hope to get here is just to know that the dependencies will behave the way that we need them to. The other services will continue to work in whatever quirky way we've codified through a test that runs in their suite. The understanding we hope to learn, get a little bit more feedback about whether this service is a good fit for our needs. Obviously, if there's frequent failures in the test that we write, maybe it reveals that we have a different view of the purpose of that service from what the team that's actually managing that service is. Of course, the maintainer learns how people are actually using their service. Are people using the service or trying to get out of the service what we expect them to, or hope that they are? Because honestly, if we're finding that they're using the service in a really goofy way, maybe the right answer is to say, hey, this isn't the best service for you. Maybe you need to go write your own. Or maybe if all of our customers are saying that, maybe this isn't the best service, period. Maybe our service sucks. We need to revisit the design of how our service works so that it can better serve the people who need it. Some guidelines for contract testing. They're written just like consumption tests, so the same rules apply. You want to use them like a normal user would, not be coupled to the private API. They're committed into the repository of the thing that you depend on. The maintainers can do a little bit of work to lower the barrier of entry for you. So maybe they can provide a type that you can subclass or helper methods to ease with setup and teardown. That way you can write a test quickly without needing to know all of the internal details of how their stuff works. Some warning signs. This is by no means should ever be considered a replacement for human interaction. Obviously, if you've got a problem with somebody else's service, the first step should not be let's write an automated test to make sure that they keep doing their job right. The first step should be a conversation to make sure that you're on the same page, to understand your needs. These are not a test of first resort, but they can be very useful. So obviously, filling out our whiteboard, these tests ensure the behavior of other services. And they help us validate and understand that our code is useful to others. Let's zoom in all the way and look at a class in our system. At the code level, at the object level, we've been talking for 20 minutes now about different types of test suites, and I haven't actually talked about TDD. And somebody might reasonably ask, well, what's the point of TDD? You already have lots of tests. But so far, we don't have any feedback about the design of our code. Everyone in this room has heard the phrase unit test. You have a definition in your mind of what you think a unit test is. You probably know multiple definitions of unit test, and you have a favorite. So I'm not going to be here to redefine the phrase unit test for you yet again. I wrote about this topic a few months ago, and I was very fortunate to get a lot of hits. In fact, now all you have to do is Google TDD failure, and I come up at the first result, which I'm proud of. The article looks like something like this. And it was so popular, it even elicited a response from the Uncle Bob. He started his post by saying that he will refute my arguments and utterly destroy my conclusions, and then, once he's done salting the ground where I used to live, at this point I was really hoping he was quoting the Old Testament and not threatening to burn down my house. Alas. Then he says, I'll tell you why I completely agree with him, which was a kindness, and I think to just kind of soften the blow of threatening to burn down my house. But if nothing else, Bob's post reminded me that there's no one true TDD, and it's important to couch what our expectations and our motivations are when we're writing tests. For example, today, when I talk about this lowest level, the TDD level of testing, in my model, the primary value far and away is discovery. It's not about making sure stuff works. It's about discovering a maintainable private API. I'm talking about discovery of tiny, boring, consistent units of code that help me break down big and scary problems into small, manageable ones. The user of what I'm calling here discovery tests, because that's my goal, is the first person to call a new method that doesn't exist yet. And they're concerned primarily with whatever inputs they need to pass that method that doesn't exist yet, and whatever outputs or side effects they're expecting that new method is going to have. Secondarily, discovery tests are concerned with the basic code design details. What does that thing that doesn't exist yet going to need? An object that does this part of the job, an object that does that part of the job. They are coupled to the implementation of the thing that they're defining. So as an example, we're going to talk about feeding zoo animals and inputs and outcomes. So if I want to feed zoo animals, I might pass in walrus and cheese. And my expectation as a side effect occurs that the walrus has cheese. And so, of course, now what? With traditional TDD, in an integrated context, I might go through an activity where I set up my RSpec with a feeds animal class, I describe a method feed, and then fear and anxiety sets in, and my face just sort of stares at the screen, and I become very lonely inside my heart. And then I give up. So instead, I've been a big fan of the book Growing Object-Oriented Software Guided by Tests by Nat Price and Steve Freeman, often called GOOSE, or isolation testing. It encourages what has been popular since SICP, code by wishful thinking. Like, when you're scared of how to break a problem down, just think of what you wish you had. So if I'm feeding zoo animals, I really wish that I could just have something that could build feed plans for me, go get all that stuff, and secondarily, provide that meal to the animal. And now I've broken the problem up into two smaller problems, and I can focus on one at a time and continue to break things down. The test in this case just becomes my sounding board. So if I have a class called feeds animals, now I know I've got a couple things that it's going to need. Something to build a feed plan for me, something to provide a meal. I create my subject by injecting those two new dependencies. And now I'm describing that feed method again, but this time I have a little bit more prompting about how I'm going to get it done. First of all, my act step, I know that when I call subject feed and I pass it a walrus and cheese, my outcome that I hope to get is that provides meal was called with some cheese and then a plan for how to feed a walrus, which I would need because I don't know how to feed a walrus. And then by having that plan identifier at the bottom, that means that, oh, shoot, I need a way to get my plan, which reminds me I need to call builds feed plan. And when its build method is called, past a walrus, it returns a plan. And now I've got a full little test that specifies just the collaboration. It's a full specification of the code that's going to be in this class, but there's not actually any logic in it. I'm only specifying that a collaboration occur. And so you could say, now I've got two problems. I've got these two other things that don't exist, and all I've done is create more work for myself. And I have, but they're two smaller problems, and they'll help me focus, and they'll help me break things down. The confidence that I get out of discovery tests is limited. Logical leaf nodes, aka the pure first-order functions in my object graph, those I'm sure work because they don't have any collaborators. I'm literally testing the behavior inside of them. The other stuff, I don't get really confidence that it works, only confidence that it's calling it the way that I originally expected it to. So in this graph, I might further flesh this object graph out. Maybe I have an object that fetches the schedule from a data source and then plans the meal by taking that response and computing an object. And then the provides meal might also be a two-parter. Maybe first it massages that data into a format that is enjoyed by the cage service, which release food will call. So fetch schedule, obviously that goes out and calls something else. But planning a meal is totally just like a normal, plain old pure function. I call it, I get a reaction. Compute portions would be the same thing. And then release food calls something else. So even in this graph of like a whole bunch of stuff, really I've only got confidence that my TDD discovery tests are going to tell me whether those two things are working. So the confidence I get is definitely limited. But the understanding is rich. First of all, the understanding that I'm getting small things, basically by default, as part of my process. It's baked in. It's free SRP. So people vacillate a whole bunch about SRP, and I think that SRP can be really really overrated when you look at a big long thing all day and then you just try to decide how you can pull stuff out. But if you're preemptively pushing out new types constantly, you're getting a bunch of tiny things just by default, and they all have good names, which I can think of worse things than having too many well-named things in my system. I know it causes panic when people see how many classes, how many methods, how many functions I write. But I'd rather err on the side of too much clarity, too much stuff, than one big, gigantic monstrosity I have to pull apart later.
I'm sorry, what's SRP?
Single responsibility principle.
Okay.
Separation of roles is also really important. It tells you, or rather, a handful of types of roles shake out of this design. So in this example, you can see that the top level is a command object. It takes some inputs and it has a side effect, and it does that by collaborating with other things. Building a feed plan is a query object. It's going to go out, fetch something, given some input, and then give you back an answer. Provide meal is also a command. It takes a more nuanced input and then has a side effect. Fetching a schedule, also a query. It's going to go query some other thing. We already talked about how planning a meal is like a logical role. Computing portions, a logical role. And then releasing the food is a command. This graph, if you actually go to a whiteboard and when you're first practicing this style of testing, this graph is really interesting because almost always it'll shake out the same way. The thing that you're building has some side effect. A page gets rendered, a report gets drawn, something gets saved to a database. Stuff on the left side of the graph will be a combination of query objects that try to gather interesting data. Stuff at the bottom center of the graph tend to be logical objects that compute things based on that data, massage the data. Stuff on the right tend to be command objects, collaborators that have a side effect. This is a really, really helpful way to have little tiny units that all serve one type of purpose, which is a great way to get consistency in your code base. Some guidelines about discovery tests is, first of all, that command and query tests, which I call collaborator objects, they should be discovering their dependencies by using test doubles. They use fake things, and if the test is hard to write, then they respond to that pain. But logical tests, they discover their implementation by actual usage. You call the function with various inputs. You test the various outputs. That means that you shouldn't be using test doubles in your logical tests. In fact, even though I own a company called Test Double, and I really love test doubles a lot, and I've written multiple test double libraries, out of the 5 test suites, only a portion of this test suite should have any test doubles in it. In general, everything else should always be real objects so that you're getting confidence that things are really working when they're plugged in. Only tests of collaborator objects should be using test doubles. Commands and queries, they typically should contain very little logic as a result. When possible, defer to a logical test where you can actually eke out a pure function. The collaboration tests are much, much easier to write if you're just looping over a thing or taking some input, passing it to thing A, and then to thing B and thing C, and looking at a return statement. And pain is good in this case. Discovery tests, Kevin Baribeau helped me review these test slides, and he points out that discovery tests are kind of like a training wheel. Once you've gotten really used to writing tiny things, they're not necessarily all that important or all that useful anymore, but they help us understand really good habits, and those good habits are discovered by test pain. If it's really hard to write a test double in a particular test, it doesn't mean that we necessarily suck at using test doubles. It probably means that our design could stand to be improved somehow. So pain is good. Pain is part of the process. And once you've gotten good at this, maybe you can start to shed discovery testing when you no longer feel any interesting pain while you're writing them. And discovery tests, as a result of this whole exercise, you can see how they yield small disposable units. So you shouldn't be afraid to throw those small units away. They are small and disposable for a reason. Refactoring becomes expensive whenever you have to make a change, you have to change a test and then change another test. So if requirements ever change, it's usually easier to just look at that big object graph and minimize the most narrow tree possible that would be affected by that change, and then literally trash it and start over. Because future us will always know the system and the business domain much more better than current us does. So we should trust that future us would probably do a better job rewriting all that little stuff anyway. Also, I think reuse tends to be overrated. We often think that reusing code means that we're getting double the bang for our buck, without necessarily realizing that if we have 2 users of a function, that means that whenever it changes, we have to keep track of its use in 2 places, or 3 places, or 4. So I don't go out of my way to reuse stuff. And this model generally creates a lot of hyper-specialized things that don't necessarily lend themselves to reuse. But when it does, it might be an opportunity to pull something out into another module. Also, extract refactors in this model of work, those are a smell. If you're writing a bunch of tests ending up with a lot of code and trying to do extract refactors, like pull a method out of one of the objects that shook out of this activity, that's going to be very expensive, because then you're going to have to pull that out, write a new test around it, update the test of everyone who used the thing above you. And it's a little bit painful. And it shouldn't be necessary if we're preemptively pushing out minimally small things. It means something failed in our workflow to define tiny things. Also, one little point on frameworks. Frameworks will fight you if you try to write discovery tests or practice goose in a test suite in your system. The reason is that frameworks and test-driven development, they both try to solve the same problem. The fundamental problem of, if left to our own devices, we are monkeys on typewriters and we will produce 16,000 line files. And frameworks help solve that particular problem by providing an orderly structure for us. Here's some models, here's some types. Extend these types, you get this behavior, organize your system this way. TDD is trying to solve the same thing, but instead of giving you that structure out of a box, it's an approach for discovering an orderly structure. So they're both trying to solve the same thing, but frameworks presume the conclusion, here, use these types, and TDD is presuming, here, you're going to land at a whole bunch of different types that are going to be completely divergent from whatever that framework wants. So as a result, discovery testing is usually at odds with most application frameworks. And so I don't practice it when I'm working inside of a Rails application, for example. I wait until I have something worthwhile that I can pull out. I'm writing an Ember application right now, and I'm doing the same thing with Ember. So discovery tests, they help us in 2 more ways. They help us know that our code works, at least the logical parts. And they help us to grow a maintainable private API inside of each of our services. One last suite to talk about. Zoom out just a little bit here, and you can see we've got a big graph of a lot of objects, and looking at our overall 30,000-foot view, one might say, wow, that's a lot of mock objects. That's a lot of fake stuff. That's a lot of test doubles. Isn't it a pain to have that many test doubles? And of course, the answer is yes, it can be. But we should keep in mind that test doubles are only used when testing those collaborator objects, like I mentioned. And better test double libraries are better. A lot of them out there aren't that awesome. They're better if they're opinionated and if they're terse, and if they make it really easy to do everything you need. Discovery tests, their goal is to try to improve the API of the dependencies of our objects. But we can't change. One type of dependency that we can't change are third-party APIs. Like if I want to call the Walrus service, I can't change its API without going all the way over there and changing it. If I tried to write a test and mock out Facebook's API, I can't literally change Facebook's API. I don't have control over it. Mocking what you don't own leads to useless pain. So the pain that was healthy in the context of a discovery test is totally unhealthy when you try to mock some third-party thing that you're not in control of. All you're going to end up with is a bunch of painful tests. And that's where I think a lot of people run into hating mock objects. So instead, I encourage folks to wrap third-party API calls that they make with tiny little adapter objects that they do own. Just start by delegating and doing nothing else. And then mock those adapters instead. And when you experience pain, then you can adjust it in the adapter layer, because you now have a level of scar tissue or indirection between you and that third party. And typically, adapters shouldn't need tests. Most tests exercise features that make use of third-party APIs, and that's totally fine. Sometimes, though, it might make sense to actually test your feature separately from that third-party API, either faking it out or just test the third-party API in a way that gets you faster feedback so you can help discover and learn and get confidence about the behavior of that third-party code. And whenever you know that you want to respond differently to third-party API's failures, adapter tests can be useful. The user of an adapter test is our application trying to understand its relationship to a third-party API. It exercises that adapter API that we introduced during our discovery test phase under realistic enough circumstances to get a handle on whether or not that third-party API is actually working the way we expect. And the confidence we simply get is when we're testing against library code, we can get an early warning that an upgrade might be unsafe because our particular usage of that API somehow changed or broke. And for network services, it can give us an early indicator of outages or breaking changes that occurred in that third-party network service. And then, of course, the understanding is actually very useful here. Not just adapter tests, but adapters themselves serve as a specification for how we depend on a third-party thing. And it helps us establish boundaries between our application code that we do own and third-party API code that we don't own. It pushes that out to the periphery of our application. And essentially, it makes our application a framework of sorts for drop-in replacements. We can easily swap out a third-party API, or we could swap out one gem for another gem if our usage of the gem is narrowed down to a single little adapter object. Some basic guidelines. Only test adapters when you have good cause. By default, you shouldn't be testing the framework. So just like with contract testing, they're very similar. One's for internal stuff and one's for external third-party stuff. Default to not writing adapter tests, but having a suite of adapter tests can be particularly useful. Warnings, though, is when you're testing a third-party network code, it can be tricky to run in CI, especially if you're in an environment where it can't access third-party services. Sometimes it makes more sense just to test these things indirectly from your safety suite, which is going to be a more integrated CI environment. And also keep in mind that adapter tests are likely to be slow in ways that are outside of your control. You can't do anything about the fact that Twitter or Facebook's API is causing your test to run slow. And so don't couple it in with all of your other test suites. Because then this third party, this egg that's in somebody else's basket, is going to be slowing down all of your feedback. So adapter tests, those are the last two things that we have on our whiteboard. They help us safeguard our use of third-party code, and they help us narrowly specify our dependencies. And so all of that to say, that was just one way that you might break up your test suite. My name is Justin. Again, I'd love if you engage with me on Twitter. Like everybody else, I'm sure, in the tri-state area, TestDouble is hiring. We're looking for awesome people to come work with us. And we're also, because we're consultants, if you think that somebody like me might be able to help your team out, or people from our team, if you guys know you need help, feel free to reach out and say hi this week, and I'd love to chat with you. That's all I got. Thank you very, very much for having me. I really, really appreciate your time.